Sorry. Wow. Oh, guess I'm just way too excited about logarithms right now. Oh, okay. All right, now, example 2. Okay, if we're asked to expand a logarithm, then the log expression is going to be written all condensed like this. It'll be one single logarithm that we're going to have to pick apart and write as a series of logarithms, either using addition or subtraction or both. Okay? Like the problem down here, you're asked to condense. You're asked to go backwards. Your answer is given, or the problem is given, as a series of logs being added or subtracted. Well, if you're asked to expand, this is the way it's going to look. This is the form of your answer. Okay? So when you're asked to expand, you're asked to write a series, a sum or a difference of logarithms without any exponents. Okay? You shouldn't have any exponents in your answer when you're expanding. So have a look. First of all, our base is 3, so every logarithm in our answer has to have a base of 3. Just remember to do that, okay? Rules of logs wouldn't apply if you had different bases, just like rules of exponents wouldn't apply, right? X to the second times y to the third is just itself. You can't apply any rules of exponents. Same thing with logs. First part, if you're expanding, you want to take every variable into account separately. And if there is a coefficient, that coefficient into account separately itself. Okay, so we have to expand this. We have the 5th root of k squared z. Well, from what you know about radicals and exponents, you should know this k is really being raised to the 2/5 power. Okay, it's like k to the 2/5, and then z to the 1/5 on top of this. Okay, so what we have is a log of, okay, k to the 2/5, that will be one of our logarithms, plus log of z to the 1/5. Now, it's addition because they were being multiplied, right? They're being multiplied up on top here, the k's and z's. You have the 5th root of k squared times the 5th root of z in actuality, okay? So you have log k to the 2/5 plus log z to the 1/5. Now, on the bottom, you have an x to the 3rd. So because you have division, there must have been subtraction being done. Okay, so you have minus log base 3 of x cubed. Now, the one little problem here is you don't want to leave exponents when you're expanding. Okay, you want to make sure you use the rule of exponents and bring the exponents in front. So you have 2/5 log base 3 of k. That's going to be your answer with the k's, plus 1/5 log base 3 of z, minus 3 log base 3 of x. Okay, that's your answer. It's not that it's that challenging a problem. Once you do a few of these, you should be totally fine with these. These are meant to be some of the, almost the freebies. You just got to be careful with the radicals. Really just ask yourself, okay, what's being multiplied and what's being divided? What's being multiplied should get addition. What's being divided should get subtraction. Okay, so we have the k's are being multiplied. They're on top. All right, so you have the exponent will be 2/5. The exponent goes in front, right? 2/5 was the exponent. It went in front here in the answer. The 1/5 was the z's exponent. That went in front in the answer. The 3 was the x's exponent. That went in front in the answer. So you don't even really need to show this middle step once you get the hang of it. You really can go just right from here, from the problem, to the answer, okay? So you'll do a few of those to practice eventually. Now,